Good morning. I am Prasannanjaneya Reddy, working as assistant professor in the department of PCE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about debugging tools. So the question is, interpret the role of hardware debugging tools in the development of embedded systems. First, bug. Bug means some error. Here, error in the sense functionality deviation. Generally, while writing the code, if any syntax errors are missed, that is called error. That is called syntax errors. If you are putting any space, commas, at that time you are getting syntax errors. If syntax is fine, everything is fine, we compile the program or simulate the program, but we are not getting errors. While running the program, if you are not getting the response in the desired manner, suppose 1 plus 2 equal to 3, that is the right answer. But I am getting 3.1 means some deviation is there. Why I am getting 3.1 instead of 3? That is called bug here in this point of view. That bugs will be removed by the designer. So first of all, we need to identify the bugs. How we can identify? Because in real time, the program is in the length of 1000 lines or 2000 lines based on the requirement, based on the application. At that time, whenever you run the program, you are getting final response. You don't know where the functional deviation is occurred. For that point, first we need to set the breakpoints. Breakpoint means, suppose I am designing calculator. In the calculator for doing some calculations. So there are different types of calculations: addition, subtraction, multiplication. So first I define the addition. So after completing the addition operation, wherever I am getting the response, at that point I am setting the breakpoint. At the subtraction, I am setting the breakpoint. At the multiplication, I am setting the breakpoint. Like that, wherever I want to check the functionality, at that point, I can set the breakpoint and run the code. Whenever I am pressing the run button, the code will be executed up to that breakpoint only. Okay. So at that time I am checking up to this line of code, I am expecting this response, like 1 plus 2 equal to 3. But I am getting 2 into 3 6, like that means, what is the meaning? Something writing code is wrong. Wrong code I have wrote here, like that. So I need to modify that code. Like that, I am finding the functionality deviations and by setting the breakpoints and identify bugs. Okay, there's a point here. Key roles of hardware debugging tools. Okay, debugging means, bug means error, functionality deviation. D means removing. Removing the functionality deviations by using these tools. So how we can debug here? Step by step execution. Allow developers to execute code line by line, inspecting variables and memory contents at each step. This granular control helps the pinpoint the exact location of bugs. Here we are setting the breakpoints, enables the developer to pause the program execution at specific points, allowing for detailed analysis of program state and variable values. Next, single stepping. It facilitates the careful examination of code execution, particularly in critical sections or when unexpected behavior occurs. Hardware analysis, real-time signal monitoring. It provides insights into the behavior of the hardware components, such as sensors, actuators, and peripherals. This helps identify the timing issues, signal integrity problems, and other hardware-related anomalies. Here, peripheral configuration needs to be verified. It allows the developers to verify the correct configuration of hardware peripherals, ensuring they are operating as intended. So, am I getting desired response or not? If I am not getting the desired response, I am modifying the configuration. Suppose I want to complete the task within the 5 seconds, but it's not completing 5 seconds means I am changing the 80512 ARM processing element or ARM to particular model number. The task is not completed within the time. Next, memory inspection, memory analysis. It enables the developer to examine the contents of memory locations, including RAM, ROM, and peripherals. This helps identify memory leaks, buffer overflows, and other memory related issues. So here time is important. If the buffer is full and the memory is not received the destination properly within the time means, what happens? May lose life and properties. I am traveling in the car, so the sensor identifying the objects in front of the vehicle is not sending the data to the dashboard within the time. What happens? The vehicle hits the object. If the ABS is not getting the data from the sensor means ABS is not worked. So vehicle is not controlled within the fraction of seconds. Means automatically the vehicle hit the object and their loss of life. That's why. Stack trace analysis provides information about the function call stack, helping to identify the sequence of function calls that leads to particular point in the program. Performance analysis, timing measurements. It allows the developers to measure the execution time of code blocks, identify performance bottlenecks, and optimize code for real-time performance. As the number of lines increases, the code length execution time increases. So we need to check that one also, how much it will take in. So example, C equal to A plus B, A equal to A plus B. If I am using this code means it requires 3 variables, so the memory occupied, more memory space occupied when comparing with this one. Okay, memory space also we need to consider. This also consider. How many lines of code you are writing here? So there are different types of hardware debugging tools are available. One is JTAG, Joint Test Action Group Debugger. A widely used standard for accessing and controlling on-chip debug functionality. JTAG is a standard method for debugging the functionality hardware. Another one is in-circuit emulator, ICE. It replaces the target microcontroller with a device that provides more extensive debugging capabilities. So in the development, during the development stage, if you are using original hardware means, if it fails frequently means, we have some problem. So instead of that one, we can use in-circuit emulator to it is working in a desired manner or not. Emulator emulates the hardware functionality. Next, logic analyzer. It captures and displays digital signals, allowing for detailed analysis of timing relationships and signal integrity. Next, oscilloscopes. In our laboratories, we are using cathode ray oscilloscope, MOCU kit to display the functionality in the hardware. We are not able to see what is going on in the IC internally. So, that the hardware is connected to our display boards, either CROs or digital multimeters or MOCU kit. It will display the big sizes with digital values. Is it better to identify the bugs, if any, and to provide accurate functionality, to provide accurate timings. So oscilloscopes measures and displays analog signals, helping to identify electrical noise. So if you look at the sinusoidal signal, if any noise is there, suppose this is my signal, in that MO, this is indicating noise. Any noise in the response. Or timing issues. So at what time the signal we are getting the amplification or clipping or whatever maybe. And other analog related problems. Benefits of using hardware debugging tools. So by using these hardware debugging tools, we can reduce the development time. First point. How? By quickly identifying and fixing bugs. Hardware debugging tools can significantly reduce the overall development time. So by using this hardware JTAG or circuit emulator or oscilloscope, we can identify the bugs very fastly and comparing with without that one, and get the desired response by modifying them. Okay. Next, improve code quality through thorough testing and analysis. Developers can produce more reliable and robust embedded systems. Suppose I am designing the code converter. If I am giving BCD, I need to get accessory number or 7-segment display. Is it counting in the desired manner? 0 to 99? Whatever the functionality I define in the circuit. By seeing that functionality in this debugging tools, if any bug is there, I can identify easily and comparing it without that debugging tools. Okay. Next, embedded system performance will be improved by using these hardware debugging tools. Means, by optimizing the code and hardware configurations, developers can improve system performance and efficiency. Optimizing this by reducing the code size without changing the functionality. So by using these debugging tools, we can check with the less number of lines of code, shall we get desired response or not? Up to that breakpoints, in between the breakpoints. Okay, and then analyze the performance and efficiency. Hardware debugging tools are essential for the successful development of embedded systems. By providing developers with the ability to analyze and troubleshoot both software and hardware issues at lower level. Once product is released and released in the market means, if any issue means, that leads to get lot of fine amounts. $1 billion fine will be paid if any issue will come. That's why in the early stage itself we need to identify means we can save the lives and penalty amount. Okay. And development time also reducing here. Again and again we are modifying means it is also somewhat difficult after releasing means. Our reputation will be damaged. If any issue will come after releasing. So, development time is very important here. By providing developers with the ability to analyze and troubleshoot both hardware and software issues at the lower level, these tools empower developers to create reliable, efficient, and high performance embedded systems. Okay. For this topic, you can refer the textbook is Introduction to Embedded Systems by Shibu KV and published by the Tata McGraw-Hill Education. That is published in the 2009. That is second edition.
Like, share and subscribe. Hit the bell icon for more updates.